So this is the further transformation homework. And essentially we're asked to sketch this curve showing the points of intersection with the coordinate axis. So first of all, I'll just draw the coordinates out. And we have x plus 3, x plus 2, x minus 1. It's pretty easy to see where the coordinates of, or actually the points of intersection with the coordinates axis in terms of the x values are, because this just equals 0. So when each of them equals 0, so when this equals 0, anything multiplied by 0 is 0. So the points of intersection are going to be minus 3, minus 2, and 1. So x needs to be minus 3, x needs to be minus 2, and x needs to be 1 in that scenario. We also know it's positive, so the x cubed is going to be positive. So because it's positive, it's going to end up going upwards. So it's going to look something. So it's going to look something like this, where this is minus 3, minus 2, and 1. We also need to find the coordinates axis, which is the y-axis. So we just need to expand this, so that becomes x plus 5, x squared plus 5x plus 6, and then x plus x minus 1, which equals x cubed plus 5x squared plus 6x minus x squared plus minus 5x minus 6, which equals x cubed plus 4x squared minus plus x minus 6. So therefore this point is going to be minus 6. Cool. So showing the coordinates of the points of intersection with the coordinate axis, sketch on separate diagrams the curves. So y equals f of x minus 3. So what happens here? It just moves 3 to the right. There goes 1, 2, 3. So this point would be 0. This point would be 1, and this point would be 4. So this would be 0. So the point of intersection would be 0, 0. This would be 1. This would be 4. And that's pretty much it. We have y equals f of minus x. So what's going to happen there? So because it's on the inside, because it's f of minus x on the inside, the negative, all it means is a reflection. And because it's on the inside, it affects the x-axis. So it just flips on the other side. So this becomes 1 here, minus 1. And then it goes to 2 and 3. So it would look something like this, where it'd go to x, and then it'd go up, and then back down again like that. So that's essentially what it would look like in terms of it being flipped around. As you can see, the y-intercept would actually be exactly the same thing, because all that happens is all the x's turn negative. So this x turns negative, this x turns negative, this x turns negative. But this minus 6 isn't affected by any of the x's. It's affected by minus 1 times 2 times 3, which would be minus 6. So yeah, as you can see, it's just a flip in the y-intercept. That's it. Okay, next question. So it says the table shows the graph y equals f of x, and the curve has a minimum at minus 3, minus 2, and the maximum at 4, 7. Showing the coordinates of the points of intersection with the coordinate axis, sketch on separate diagrams the curves y equals f of x plus 2. Well, y equals f of x plus 2 is just going to look like this, where this value just moves up by 2. This is going to be at minus 3, 0. And this would be 4 and 9. Because it just moves up by 2 vertically. This is minus f of x, so the minus is on the outside, so it actually flips upside down in terms of the x-axis. So it would look something like this, where this would be 4 and minus 7. And this would be minus 3 and 2. So the turning points would be flipped around because the y intercepts are, the y values are negative. The y-intercept is also going to be the negative version as well. We have f of x equals x squared plus 4x plus 5. Express f of x in the form x plus a squared plus b, and state the coordinates of the minimum points y equals f of x. So all we need to do here is x plus 2 squared minus 4 plus 5. So it's completing the square. And that gives x plus 2 squared plus 1. So the turning point is going to be minus 2 and 1. So the minimum point of this is going to be at minus 2 and 1, because this is and it's a minimum because it's a positive. So it looks something like this. And that point is minus 2 and 1. Sketch the graph of y equals f of x, showing the coordinates of the intersection with the coordinate axis. So if this is minus 2 and 1, then it would look something like this, where this value is 5 because the y-intercept is going to be 5. Pretty straightforward stuff. Find the minimum points of these curves. So this is 2 times as big, so this would be, so basically what happens at the beginning, I'll just color it in a different color. There's a vertical stretch of 2, so you can kind of think about it as the y values getting doubled. So this point here would be -2 and 2. This one is a vertical, well actually a horizontal, so because it's on the inside it's going to be horizontal in terms of the x values, and it's a horizontal compression of 2, so it's going to be half as big, so it'd be -1, and so at the same height it'd be -1, 1, so it would look something like this. So basically this should be this so you don't need to sketch this, you just need to find the minimum point, and this minimum point is going to be -1 and 1. So this graph, the diagram below shows the graph of y equals f of x. So we have y equals f of x, we need to sketch the graph y equals the modulus of f of x. So the modulus just means it's positive, so it's pretty straightforward. It's just going to go upwards like this, and this is also going to upwards like this. Oh my goodness, not like that, but like this. It needs to, the magnitude needs to stay the same. So this would be 3, and the positive version of the y, which is 3 and 3. And that's literally it. This side stays the same. So I guess the graph would look something like this. Bang, bang, like that. But I'm not going to draw that part. Cool. Actually, I'll highlight it just so that's a little bit more accurate. So you know what part is. Oh my goodness. So this is part B of that question. So we need to find the f of modulus x now. So the modulus x just means it's going to be the modulus of the x values on the inside. And all that happens with that is the sketch just kind of flips on the the y axis. So it would look like, oh, sorry, not like that. It would look like this, and it'd go down. And then go on the other side, it'd go down like that. And that's it. So whatever happens on the right side happens on the left side in the mirror dimension. Actually, that makes no sense. Not mirror dimension, but you know what I mean. I don't know. Actually, I'm just yapping. Cool. So solve for x, given that the modulus of that is that. So with these types of questions, there's actually going to be 2 answers. So I'm actually going to do question A last, just because it's the most confusing one. And I'll do question B first to begin with. So question B here, we have the modulus of 3x minus 1. And whenever we have questions like this modulus where we need to solve it, there's actually going to be 2 case scenarios. Case scenario 1 is 3x minus 1, which equals 5x minus 11. And case 2 would be the negative version, which is 3x minus 3x plus 1, like that. And that equals 5x minus 11. So let's do case 1 first. So case 1 equals 2x, and I'm going to add 11, so it equals 10. So x equals 5. Yeah, and then case 2, that is 8x equals 12, so x equals 3 over 2. Cool. So those are 2 values of x. Because if you think about it, what a modulus line looks like is something like this, right? And then this is a straight line graph, so it looks something like that. So here it touches 2 points here and here, and those are the 2 points that we need to find. And that's the, if we had to do it algebraically, this is how you do it. You find case 1, and case 2. Cool. So yeah, so we need to solve the following inequalities for x. So the modulus of 2x minus 1 is less than 4. So we have the modulus of 2x plus 1. So we just do 2x minus 1 is less than 4. Do the 2 case studies, and then minus 2x plus 1 less than 4. So 2x is less than 5. So x is less than 5 over 2. And this is 2x is greater than minus 3. So x is greater than minus 3 over 2. So yeah, so the inequality is going to be minus 3 over 2 is less than x, which is less than 5 over 2. So that's the region. Graphically, this would look something like this. So 2x minus 1 would look like this. And then 4 would be like, because this is 1, so 4 would be here. So when is it less than 4? It's going to be when it's minus 3 over 2 and 5 over 2. And that's the value, because this is a half as well. So solve for x. So we need to solve for x in this scenario. So it's 2x plus 3, the modulus of this. So here, instead of making all of this negative, what I can actually do to make my life easier is I can make the right side negative. So I have 2x over 3 over 2 minus x equals 5. And then the case 2 would be 2x plus 3 over 2 minus x equals minus 5. And it's essentially doing the same thing, but making my life a little bit easier. So I have 2x plus 3 equals 10 minus 5x. And then that equals 7x equals 7, so x equals 1. And then on the other side, I have 2x plus 3 equals minus 10 plus 5x. So then I have 3x equals 13, so x equals 13 over 3. Cool, so those are the two values for x. So yeah, and then the final question, we're told that the figure above shows the graph of y equals f of x between 1 and 9. The points 2 equals 3, 5, and 7, 2 are turning points on the graph. We need to sketch this. So I'm going to do it on the same graph just because. So essentially what happens here is there's a stretch vertically by 2. So this becomes all the way up to 10. So the x values stay the same, but this becomes 310 instead. But then from there, it's a minus 4. So it actually goes down. So it actually would be 3 and 6. So this turning point would be 3, 6. And then this turning point would be 4 up and then 4 down. So this would be 7 and then 4. But then after the vertical shift downwards, it would be 7, 0. So it'd be here. So the graph would look something like. So the graph would look something like this instead. Just a sketch, so it doesn't necessarily matter if it's completely accurate. It's just what matters most are the turning points. Cool. So yeah, so then we have y equals the modulus of f of x. So this part stays completely the same. The only part that changes is this part here. The turning point for this coordinate is going to be the same as this as well.